Hello there, it's Jason Gorman from Codemanship with the third of 6 special screencasts to celebrate 6 years of Codemanship. In this screencast I wanted to answer a question, or attempt to answer a question, that comes up quite often in TDD training and coaching. And to illustrate that question, I'm going to show you a little bit of code. So here's a parameterized test for a Fibonacci sequence generator, something that calculates Fibonacci values at a particular index, a particular position in the Fibonacci sequence. And as you can see here, it's a parameterized test. So we've got a whole bunch of input values for the actual index that we want. And what I've done in this test is I've actually calculated inside the test what the answer should be. So we can keep adding values and we don't have to keep recalculating what the answer should be for each value. Now, we generally recommend against doing that for a couple of very good reasons. The first is if we take a look at the implementation that I'm testing here, it's almost identical. We've actually duplicated the implementation of the Fibonacci algorithm in order to test the algorithm. So it's a duplication of code and a duplication of effort. But also, if you think about it, because these are almost identical, in fact, they're pretty much the same, when we run the test, we would expect them to pass because we're testing this algorithm with the same algorithm. The implementations are almost identical. So is it really a valid test? It's kind of more of a self-fulfilling prophecy that these produce the correct answers because they are the same algorithm and the same implementation. So for those two reasons, we tend to discourage developers from doing this. Normally it's better to calculate what the answer should be and then feed those in as parameter values to the test, the expected results. But there are exceptions to that, and I wanted to illustrate one of these exceptions using an exercise for development teams that I highly recommend you have a crack at, actually, but that's not the point of this screencast. If we go and take a look on the Codemanship website, there's a hidden page. If you navigate to a Team Dojo section, codemanship.co.uk/Team Dojo, this hidden page comes up with a whole bunch of resources for this team exercise, which is designed to stretch the muscles that individual programming exercises can't, like how to collaborate, and also things we do very rarely get practice at, like creating build scripts and setting up source control and all the kinds of things that we would normally do very rarely, if we do them at all. Normally you might be on a team where other people do that kind of work and you never get any practice at it. So I highly recommend having a go at this, but that's not the point of this screencast. I'll just show you the slides for this. This is an exercise where essentially what we have is we're asked to build a social network for programmers, where programmers, when they join the network, can recommend other programmers that they know or they've worked with. For the purposes of building strong development teams, you pick a developer you like the look of, and then you build a team around them based on their recommendations and skill sets and so on. One of the requirements for this ProNet example is to be able to calculate the rank using the Google PageRank algorithm, calculated the rank of programmers within the network. How important are they based on who recommends whom, and the rank of the people that recommend them, of course. So much the same way that web pages get a rank based on who links to whom, and you know, the rank of the pages that link to your page. Same kind of thing here. Now the Google PageRank algorithm, it's a bit fiddly. It's an iterative algorithm, and basically what we're doing is we're applying some function to the sum of ranks, page rank, some proportion of the rank from each of the pages that links to us, each of the programmers that recommend us in this case. And in order to calculate the expected results for this particular acceptance test case that we've been given, you'd have to do thousands and thousands of calculations by hand. So here's the exception. When it's easier and quicker and cheaper to write a program to calculate the expected test results, then you should do it. But it comes with two important caveats. So this is a case where if we tried to sit down and calculate these on paper or do them, you know, in our heads, it would take us a very long time. It would probably be much quicker to, for example, knock up an Excel spreadsheet to do that, or to write some kind of program to do it. So that's what I've done. I've written a spreadsheet, and we can see here we've got represented as a table, we've got our ProNet example network from the acceptance test that we agreed. and we can see who links to whom initially there by the numbers. If there's a number in one of those cells, that means that that programmer on the left, in the left-hand column, recommends the programmer in the top column, and it represents essentially the same information. So I've knocked up the spreadsheet. There's a bunch of macros, VBA stuff that goes on in the background. It's all kind of hard-coded within the networks. And I want to make two important points before I finish. The first point is I started with a test that is very simple, to which I already know what the answer should be. If we run this particular example where we've got two programmers, A and B, and they both recommend each other, we would expect that the resulting ranks that are calculated will eventually converge on one each. So they both end up with a rank of 1. I can just prove that by running the test. So let's run that over and over again. You have to run this maybe 40 or 50 times. If you watch, the output is being fed back into the inputs here. And eventually you will see that they will top out at 1, exactly 1. So we do one more there, so 46 iterations. I don't want to explain PageRank too much. All you need to know is it's an iterative algorithm. You have to do it many, many times. And eventually the answer should converge and sort of stabilize. So that's the answer we would expect. That's the common sense answer that we would expect. And it's very important to have at least one example in your test data generator that is grounded in the real world, grounded in answers that you already know to expect, so that you can have some confidence in the test data generator itself. So this test is designed to give confidence. And we've got more complex tests that will be very, very difficult to do by hand. And in the case of the ProNet one, very, very difficult. It will take a long time when you probably get answers wrong and so on, all the stuff that tends to happen when you do things by hand. So this is what the spreadsheet is really for, is to calculate these results here. Let's run this one and see what happens. So dum-de-dum-de-dum-de-dum-de-da. As we bottom out, a similar number of iterations, maybe 45, 46 iterations before these answers stabilize. Let's keep going, and they kind of look stabilized now. It's going to run for quite a while, but it's not going to change. So those are how we calculate those page ranks using this simple algorithm. I can show you in the background. There's some code that I had to write to make it all work. Let's edit some of that code so you can take a look. You can see that there's a bunch of VBA modules here that I've had to write. There's not a massive amount of code, and it's all pretty much hard-coded for specific examples, plus some sort of helper functions to reset cells and feedback data and so on and so forth. So it's all pretty much hard-coded, and it is therefore a very different implementation to the one that we're eventually going to write. The actual code that we write to calculate PageRank is going to be very different to this. It will come up with the same answers, we hope, and this is very important. If you have two different ways of calculating the same set of answers, and they both agree with each other, they both come up with exactly the same results. Robert Martin, Uncle Bob, uses the analogy of double entry bookkeeping, where when you're keeping your accounts, you basically do the same calculation twice in two different ways, to give you a high confidence that if they both come up with the same answer, it's much more likely to be the right answer, because the chances of them accidentally both coming up with the wrong answer in different ways would be slim, very remote indeed. So this is the same kind of principle, really. We have a different way of calculating the answers. It's automated, so we can do these complex calculations. It's grounded in the real world. This is very important. We ground it with examples that we know the answers to, so that we can then build on that and have higher confidence in the other results that we're getting. But also, and this is very important to remember, we're not just using this spreadsheet to test our implementation of PageRank. We're also using our implementation of PageRank to test this spreadsheet. In other words, what's important is that they both agree with each other. The chances of them both being exactly wrong in different ways are so remote that you can have much higher confidence in your results. So here's your exception to the rule. It is okay to write programs that calculate test answers if that is the quickest, cheapest, easiest way of doing it, and just as long as the method that you use to calculate the answers differs in the implementation and in the test data generator, and also that the test data generator is grounded in real world common sense examples that you already know the answer to. So testing at limits, for example, like what happens when it's 0 or so on. So those are the three caveats. One, it's got to be the cheapest way of doing it. Two, it's got to be a different way of getting the same answers. And three, it needs to be grounded in common sense. You need to at least sanity check it with problems you already know the answers to give you confidence that it's doing the calculations correctly. So there you have it. That's one of the cases where it is acceptable, it is okay to write a program to calculate test data. This would spit out values that we would then feed maybe into a parameterized test. It's also, of course, it would be okay to if you knew a different way of writing this in, say, Java, if you were implementing your PageRank algorithm in Java, then that would be okay too. I'm not saying you have to use an Excel spreadsheet. I just find Excel spreadsheets quite useful because it's quite quick to knock something up for specific test cases that will do complex calculations for you without having to go through all the hell of developing a real solution. Okay, so that's our third screencast. Look forward to the fourth in the next week or so. Cheerio, bye.